Hey, thanks for joining us on Math Extra. I'm Rob Leichner, and as you know by now, I'm a math person. And I'm still a math person that needs a haircut. But in fact, no matter what you might think, we're all math people. So let's get started, 7th graders. Let's do this. Let's do the math on Math Extra. So today, we're going to be talking about proportional relationships. What the heck is that? Proportional relationships is when something increases by the same factor each time. So it's a multiplicative, that's a tough word to say, multiplicative relationship by multiplication. But we're going to talk about it through some really fun things. Have any of you ever heard of rugby? It's the sport I used to coach when I taught at West Mac, and it's kind of like a mix between football and soccer. But when you play rugby, you're trying to score in the try zone, which is like a football end zone. Every time you score what's called a try, and we're about to discover what each try is worth and how we can win the game. So let's take a look. We're thinking about a rugby game. There's a rugby ball. It looks kind of like a football, a little bigger, no laces. But let's say there was a game and the USA was playing against New Zealand. New Zealand has one of the best teams in the world in rugby. But the USA won. We had 25 points and New Zealand, they lost. They only had 10. So we know that the US scored 5 tries to get its 25 points. We also know that New Zealand scored 2 tries to get its 10 points. Can any of you figure out how much one try is worth from that? Take a second, think about it. Did you say 5 points? Because you'd be right. One try is worth 5 points. Now, how much would 4 tries be worth? Well, let's see. If one try is worth 5, 4 tries would be worth 4 times 5, or 20 points. How much would 8 tries be worth? 8 times 5, or 40 points. Now, one of the most important things about all proportional relationships, if we have 0 tries, how many points is that going to be worth? Well, think about it. If you don't score any points, 0. Every proportional relationship goes through that point 0, 0. And we're about to see how that looks visually on a graph. We have our table here. We've seen our relationship. We know for every try is worth 5 points. If we multiply the number of tries times 5, we get the total number of points. Now let's see what it looks like on a graph. Luckily enough, I prepared this graph before we started, kind of like one of those cooking shows. And we have here, we can see there's our exact same table as the last slide, a little neater because I typed it instead of wrote it. But here, you can actually see the coordinate points. So x equals 0, y equals 0. X equals 1, y equals 5. X equals 2, y equals 10, and so on. The x-axis represents the number of tries that were scored. The y-axis represents the number of points. Now, take a look at those points that are on the graph. Did anyone notice a certain shape that they look like they formed? Maybe you noticed it looks kind of like a straight line. Wow, because they're all proportional. Now, it's cool that it makes a straight line, but it can also give us some more information. Watch this. Let's say we want to know how many tries or how many points were scored when there were 6 tries. We can just look on our line. If we have x equals 6, we see where y is, So we come up from the 6. We go across on the Y. And we can see that that's 0.630. So when we score 6 tries, it's 30 points. And we can tell that visually because it's the point on the line. Now, every proportional relationship, we also said it'll go through the origin 0, 0, which is very important. When you get to 8th grade, you'll learn about sometimes when they don't. But every proportional relationship like this goes through the origin 0, 0 and makes a line. So next, we're going to talk about ways to write equations for these, because sometimes it can be really good to make graphs and represent it visually. Sometimes these numbers will be too big, or it'll just be easier to not have to draw a graph out every single time. So let's take a look. There's our same table, same number of tries, same points. And we're going to look at the USA's score. They scored 5 tries and scored 25 points. Now, every proportional relationship, having trouble saying that too, has the equation y equals some number k times x. The x and the y represent those values in the relationship, the tries or the points. K is what's called the constant of proportionality. Can everyone say that? Constant of proportionality. And that k is going to be the same for the equation the whole time. If we take a look at this equation, y equals kx, and we're looking at the USA's total here, 5 tries, 25 points. So we've got 25 equals k times 5. Now, what number times 5 equals 25? One way we could figure it out is dividing both sides by 5. And k equals 5. So our constant of proportionality is 5. Our equation will be y equals 5x, because k equals 5. And now, if we know any number of tries for x, we can figure out the number of points for y. And we can do it without drawing a graph and without listing out an entire table. We can figure it out from the equation. Ready to try another one? Awesome. So another way that you can that we can see constants of proportionality is through shopping. I personally like sports much better than shopping. I know my wife likes shopping much better than sports. So hopefully we can show how constant of proportionality applies to everybody. So let's take a look. Since we can't go shopping right now, you decide to buy 3 shirts online. Now, before tax or shipping, your shirts are going to cost $38.85. Now you tell your friend about this, and your friend wants to buy 7 of that same shirt. How much will all those shirts cost? So you can see here, I started by setting up my table. Now we've got some pretty important numbers there. I didn't list all the numbers. We could fill this in if we want, 4, 5, 6. We could list out the whole table, but I think I'm going to try a little different tactic. How might you go about this? What do you think is the most important thing we'll need to know if 3 shirts cost $38.85 and we want to know how much 7 shirts will cost? Thinking? Thinking? Got a plan? Well, I got one. I want to know how much 1 shirt costs. And there's a couple of ways to do that. If 3 shirts cost $38.85, I could just divide by 3. $38.85 divided by 3 will be $12.95. You can check me, but I promise you it's right. Now, once again, 0 shirts. If I'm not buying anything, am I going to pay anything? I better not. So 0 shirts is going to cost $0. That's another hint that it's going to be proportional because it's going to go through the origin. Now, if 1 shirt costs $12.95, how are we going to figure out how much 7 shirts costs? We are going to multiply. Now, ready for another trick? $12.95 times 7 looks like it's pretty tough to do. You're gonna have to write all that out, might even have to get a calculator. But $12.95 is 5 cents less than $13. So if I can multiply 7 times $13, 7 times 13, 7 times 10 is 70, 7 times 3 is 21, $91. And then if I can multiply 7 times 5 cents, 35 cents, all I have to do is subtract $91 minus 35 cents, and I know it's gonna cost $90.65. Some of those mental math tricks can really make math, first of all, a lot more fun, but also a lot easier for you. You don't have to worry as much about the calculation if you can kind of figure out some stuff like that in your head. I do want to show you the equation real quick too though. So we just figured this out based on the table, but if we look at the equation where X is the t-shirts, Y is the price, K is the constant of proportionality once again, which is the price of 1 shirt. So Y equals KX, 38.85 equals K times 3. Just like last time. If we divide by 3, which think about it, that's the exact same thing we did here in the equation, in the table. We divided by 3, then we know K is going to equal 12.95, and our equation, Y equals 12.95x. So for every t-shirt we buy, it's $12.95. Also, if we multiply the number of t-shirts that we buy times $12.95, we'll get the total price. Now that's exactly what we did using the table and using our number sense, using our common sense. But if it's harder numbers or it's way bigger numbers, then we can use the equation also. So I hope that helps you with constant proportionality. It's one of those big words, a lot of your teachers will say COP or even COP to refer to it, but it's really, really important because it shows you that straight line on the graph when it's a multiplicative relationship. In 8th grade, your teachers will call that slope. But it also shows how the table connects to the graph and how it connects to equations with an X and a Y. For me, teaching math is really fun when I get to hear from a student and help them solve a problem. It's been so long since we've gotten to see students in the school buildings, and that's my favorite part of teaching. So this is my favorite part of the show, when we hear from our caller of the day. Hello,
Hi.
Welcome to Math Extra.
Hi,
Hi, what's your name?
Darion,
Darion, nice to meet you. And where do you go to school?
Northeast Middle School.
Northeast, I love that school, great school. And who's your teacher?
Miss Gennaro.
Miss Gennaro, she's wonderful.
Yes.
Do you like math, Darian?
Yes.
Awesome. What's your favorite thing in math?
Well, just to learn it and understand it and
Awesome. Well, hopefully we can help you understand even more today. So what's your question?
why do proportional relationships make a straight line on a graph?
Oh, great question. And thanks for asking, because I did talk about that, but I didn't explain why. Think about a proportional relationship. We're multiplying by the same number every time. So, Darian, let's say we had a constant of proportionality of 5. So that means we're multiplying by 5 each time. So if we have one object, what's our y value? If x is 1, what's our y value going to be? If the
1.
I'm sorry?
1.
So it's 1, but 1 times 5 for the constant of proportionality. What's 1 times 5?
Oh, 5.
5, exactly. And if it was 2 was our x, what's our y going to be?
4, right?
Well, sorry, the constant proportionality is still 5 because it stays the same every time.
Okay. 10.
10, exactly. I'm asking you some tough ones. You're doing good. Now, what if the constant proportionality is 3? I'm sorry. If the x is 3, the constant proportionality is 5. What's our y going to be?
15.
15. And 4?
20.
20. Darian, are you starting to see a pattern here?
Yes.
What's the pattern?
So like every time you go up 1, then you're multiplying it up another, like you're going up another 5. So
every time you go up 1 on the x, the y goes up by 5. Great job. So if every time we go 1 right on the x, we go up 5 on the y. Right 1 on the x, up 5 on the y. Right 1 on the x, up 5 on the y. That line is increasing by the same amount each time, so it's going to stay straight. So if we have it where that line is going up at a constant rate the whole time, it's going to be a straight line. Does that make sense, Darian?
Yes.
Awesome. And Darian, just wait till next year. I know you love learning and understanding, because next year when your teacher calls it slope, you're going to get it even better.
Okay.
Great job. Thanks for calling, Darian.
Thank you. Have a good day.
You too. 7th graders, are you looking for a challenge? How about a little Math Extra, extra credit? Solve this problem based on what we talked about today. Let's say if you get 15 test questions right, you get a 60. How many test questions do you need to get right to get a 90 and get an A? And that's it for today's 7th grade lesson. But coming up next is Mr. O'Neill working up something special for our 8th graders. Thanks to all my 7th graders out there, and remember, we're all math people. Stay safe, and we'll see you soon.